So this should run a YouTube upload of this stream and do the automatic 15-minute break. I'm not relying on justin.tv because they have some quality issues. So now if we switch over the code, we can start programming. And that's here. To remind myself and everybody what I'm doing, I'm going to go over the setup. This is Emacs on my Ubuntu box. And I have a VNC connection to my Mac, which edits the same code through a shared Samba drive. And I do all the editing in here, in Emacs, and I build and check errors here in Xcode. So I think that's pretty easy to understand. I'll show the app because I have to remember what we did last time, which was yesterday. We were implementing, yeah, I went offline and programmed a bit last night. It said build failed, so I have to figure out. Oh yeah, okay. Yeah, I'm really not used to Xcode 4 yet. Xcode 3, 2.5, 2. This is the biggest jump for me. Yeah, so apparently I added some files, and Xcode does some automatic copy and paste stuff, so I need to deal with that. So it says my Xcode error is, and vector not found. Okay, normal physics entity.h vector not found. Okay, I understand what that is. Yeah, with C includes, you can get this weird thing where, yeah, if you include the library files up ahead. Actually, I don't know why this is an error then. So let's look at the complete error. Line 10, vector file not found. No, I don't really know why this is an error. I do know why it's an error. Yeah. This is something I do repeatedly whenever I create a new class. I'm writing C++ and Objective-C, and I'm mixing them. So I need to do the simple change of changing to an MM file, and that will make the compiler use the Objective-C++ compiler instead of the Objective-C compiler, which doesn't allow templates. So if I just add M like this, so now you know that there's 2 M's, and recompile, shouldn't be an issue. And even though normal physics object is a MM, it's because it's included through the pitch shift effect class, which is an M, Objective-C, and that will cause the error. So it built, and now it's running. Takes a little while to start up on the iPhone. But the last thing I remember implementing is these. Yeah, so if you look, see the little green thing on the bottom? That's now the waveform, and it's picking up on my voice. So if I say a long sound like, hold on, I'll try singing into it. That didn't quite, well, it did work, but it's that slightly longer one. If I vary the amplitude now, it should, the waveform should kind of zig and zag a little bit. I'm going to restart it because it's a little, I don't have a mechanism to clean up the thing yet. Once there's a lot of objects, it gets hard to control. We're also doing this weird, I better shut up so I can record. So, there you go. Whoa! Wow! 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 Okay, so you get some of that shakiness in there, and you're not supposed to really speak that close to the mic, otherwise you get clipping. But that's where we're at. So that's the echo effect. When I say something into it, it spits it out with some echo, and you can kind of hear that even through my crappy audio setup right now. I recently moved back to Hawaii and don't have all my gear set up. So, what are we doing? Well, as we found out from that compiler error, we have this new class called pitch shift effect. You know? And it basically looks like this. It's empty. What was that? Yeah, I don't know what that was. But here is that. And let me pull up a similar effect class, a related effect class, and that will be the echo effect. And this is the effect we heard just now. Note that our effect classes are pretty small. We only have a couple of them, but it's just the raw block processing, DSP processing, and that's it. And then the rest is all handled in the superclasses, the effect entity class. And so we can essentially just take these stubs and stick them in our pitch shift effect class. Yeah. And then change them around a bit. Since they're so small, it's well, if we do create some errors or whatever, I mean, it'll be pretty quick to debug. And we should do the same for the H file. Let's just compare. What was the other one called? Echo. That's a weird message. Oh, I know what that is. I kind of want to fix that error. Yeah, so the thing is about Emacs, there's a couple annoyances to edit Objective-C, and in particular the Objective-C++. Yeah, Objective-C++ isn't recognized. So yeah, here you get a M going to a CPP. And I think there's probably just an error here, like a compile error. That's what I found out last time, but maybe that's not the case. This looks like OK Lisp, if such a thing can exist. That should be fine. Yeah, I don't know where that error message is coming from. I mean, this is a little scary, but this is one line, right? Yeah. Alright, anyway. Let's not worry about that. Alright, so our effect entity has this, because it was doing echo, it needed a long delay buffer. Now, for a pitch shifter, we don't really need a long delay buffer. And it's a good time to start drawing stuff. There are many different types of, many different ways you can implement pitch shifting. And a lot of it depends on what you're going for. So, let me just start drawing stuff. The most basic method I can think of is, and yeah, the one that's easiest to implement as well is you just do some kind of, you have a time stretcher, so time stretch. I think I spelled stretch wrong, right? And then you also have I don't know if there is a there's a rectangle drawing. Well, whatever. I like drawing like this anyway. Although, yeah, there you go. Time stretch. So, for example, this time stretch can take a sound like hello and turn to hello. Just make it twice as long or whatever. Yeah, and I'll then there's the other option, which is no, not the other option, the other half, which is the resampling. Okay. Oops. Whoa. I don't know what that was about. Let's redo. Control R. Isn't that interesting? Interesting way to do. Yeah, this program has a lot of new quirky things, conventions, but it's nice and it's free. So with these two things you get a poor man's pitch shifting. And I suspect this is the way a lot of the apps will do it, because this is the easiest way to go about it. Now, to get started, this is what I want to implement, because I just want the basic effect in there. And this basic time stretch thing, this part is recyclable. We can reuse this in a lot of other parts of the code. Now, even within time stretch, there's a lot of different techniques you can use. One is a simple, so given a waveform, I'm going to just draw some, that's not a waveform, that's not a good waveform, but something like this. This is just the energy I'm drawing. Yeah. A basic time stretch can just take, say, I should draw in a different color, huh? Yeah. You just take chunks like this chunk, then you overlap and take this chunk. So, and then you have an envelope that can be a sinusoid or something, probably more like a Hanning window or something. Just like the entire psi form shifted up instead of being turned into 0. It should go from 0 to 2 and divided by 2. So you can take these kind of envelopes and you add them together, and then you just change the spacing. So if I just added these together, for one thing I would lose some energy, and I can compensate for that by multiplying by like 1 over 0.7 or something. But note that if I put these envelopes closer together, the operation doesn't change, and I will get a longer sound when I do it repeatedly over many. If I space them out, you can get the opposite. You can get time shrinking, I guess. It's the same. You've got the same effect, but that gets a little problematic because you don't want to have really gaps in between. Okay. So I think first we're going to implement a time stretch effect. Is that reasonable? If we're going to use it in the pitch shifter, yeah, I think that's okay. It's a subcomponent, right? Yeah, and a resampler as well. We can do those both individually. And this is a good place to maybe break out the code. Right now we have just